K-diff pairs in an array. So for this question, the problem is asking us to find out a given array and a number k. So what is the number of unique k different pairs in the array? So to take an example, we have an array as an input and we have a k equals to 2. So we're trying to find like for each of the pairs, right? So for example, this and 3 and 1, whether the difference between 3 and 1 is 2. So in this case, yes, 3 and 1, 3 minus 1 is 2. So this is a valid answer. And also valid answer in this array is 3 and 5, right? So 5 minus 3 is also 2. So the number of unique pairs we can find in this array is 2. Because other than that, all the other pairs, we cannot find a difference of 2 for this. Okay, so note that we need to find all the unique ones, right? Like 3 and 5 is 1, and 5 and 3 is also 1, but they are the same pairs, essentially. Okay, so the second example we have is like k equals to 1, and we have all the pairs available in here, so the answer is 4. And note that k is also be able to equal to 0. So if that's the case, then we're going to find that if there is a number that is the same appeared twice or multiple times, in that case, like we can find a pair 1, 1 that is having a diff of 0. But we cannot use the same number twice if it only appears once. Okay, that's something we should note right on. Right. So by knowing this problem, like how do we solve it? The intuition is we can iterate through all the elements of the array and then try to find the pairs, right? So we can find this is one pair, this is one pair, and etc. By iterating all the pairs, we're going to find out each pair whether the difference is k or not. In this case, it's 2 or not, right? So this took n squared time complexity, which is not good enough. So how do we optimize this our solution? So by thinking like the goal is to find out whether two numbers, the diff of two numbers is 2 or not. For example, like 3 and 1, right? If 3 minus 1 is 2. So it's very similar to the two-sum problem we have encountered before, where if we want to find out whether 3 minus a number is 2, we just need to find out whether 3 minus 2, which is 1, is in the data structure or not, right? So suppose we have a set that can store all the numbers in there, and when we encounter 3, instead of iterating through the pairs and find out whether 1 is there, we can just check the set and to see, okay, so 1 is there. Then we have solution. We have a valid solution. We're gonna increment our result by 1. So similarly, the other way around is if we have a 3, we're gonna find out whether there is a number that minus 3 is 2. Right? In this case, we're gonna see, okay, so 5 is in our set, and then it's also a valid solution. We're gonna increment our result again, right? So this is our intuition, having a set to store the pool of numbers available, and then use a similar way where we did two sums, and then find out whether we increment the result or not. So there's one catch. One thing is, if k is equal to 0, right? So if it's equal to 0, we're gonna find out whether there is a 3 appear in the array again, because we cannot use the same number, because the number we're looking for is going to be another 3, right? In this case, like there is no 3s in the array, so we cannot increment our result. But when we iterate through 1, then we're gonna see, oh, okay, there's another 1 in there. So in this case, we can see that set as a data structure for this problem is not enough. This is because if we have a set, then 1 will only appear there, right? Like whether it's in the set or not in the set. But in reality, we want to find out whether the count of our number is more than 1 or not. So this is by seeing that, we know that we're going to use a map. So key of the map is the number. The value of the map is going to be the count of the number, right? How many times it appears. Right. If it's more than 1, then we know if this k is equal to 0, then we're gonna increment our result by 1. All right. So by knowing this, another thing we need to consider is when we see this number, when we iterate through this number, after we do that, we're gonna never use this number again, because by first iteration, like we talked about before, we find out whether 1 is there, because it's like this number minus a certain number is 2, and also a certain number minus this number is 2. So we find out both ways. And 3 cannot be our answer again in the pair because we already found all the pairs contain 3. So after each iteration, we're going to remove the current number from the iteration. So we never have to have it again to prevent the duplicate. All right. So let's take a look at the code. So like we talked about before, we have a map as a data structure, and we're going to initialize the map by iterating through the array of numbers and put the number as the key and then the count as the value, right? So after initializing the map, then we have a result as set to 0, and we're going to iterate through the entry set of the map, right? So for each of the number that we talk about is the same way we determine the two-sum, right? So we have a number, we have a count, and we have a pool. So the pool is going to be the key set of the map because like it contains all the distinct numbers within the map, right? So we're gonna check if k is equal to 0. Obviously, like if the count is greater than 1, then we know that we can find a pair. So we result plus 1. Otherwise, we don't, right? If its count is 1, then we know that it's only a single number. We cannot use it. And on the other hand, if k is not equal to 0, then we're going to check the pool whether it contains number minus k and number plus k. So this is both. It works for both ways. If we find an answer, that's where like if we encounter 3, we can find a 1 and then 5, right? So we're gonna increment our result if those cases are valid. And finally, we're gonna remove 3. We're gonna remove the current number from our pool because we never gonna see that number again as a unique pair. So finally, we return the result of the number of unique pairs we can find.